Hi everyone, welcome to the channel. In today's video, we're going to be solving a problem in equilibrium in 2D. And in this question, we have a beam AD that carries the two 40-pound loads at point A and C. And we know that the beam is fixed at point D and also another cable at point B, which is holding the counterweight of 100 pounds. So we need to determine the reactions at point D. So we're gonna start with the free body diagram. If we So we have to start with all the forces that we have in this question. So let's call this point A. We have the 40-pound in here. At point B, we'll have the tension in the cable, and at point C we have the other 40-pound force, and the reactions that we have, since it's a fixed support, we will have dx, we'll have dy, and again, since it's not a pin, we'll have a moment as well. So let's show our x and y axis too. So this will show the positive side for x and y. And for the free body diagram, this is pretty much all we have for forces. And if we look at the cable, we'll see that the cable is attached to the weight. And since it's a one single cable, the tension in every single point of this cable will be the same as the weight. So we know the tension in the cable will be the same as weight, which is 100 pounds. So obviously we are in equilibrium. We'll have the sum of all forces equal 0, as well as the sum of all moments in equal 0. We're gonna start with our fx first. So the only force that we have in x direction is the dx, which has to be 0 because there is no forces in x direction. So let's call our point. So far we found one of the reactions at point D. The other equation that we have will be the y equation. So we simply have the tension in the cable positive minus 40 plus dy equals 0. And from here, it's easy enough to find dy, which will be 100 minus 80, which when it goes into the other side of the equation will be negative, and we get minus 20 pounds. And this negative sign in here shows that the assumption at the first place for the direction of dy was not correct, and it has to be downward. So we found the second unknown actually at point D, and the only thing that's left is the moment about point D. So we need to find a moment about a point to find the last unknown. The easiest one would be the D, since we have all the unknowns at point D, but now that we started with F equations, it really doesn't matter. Let's just go with the at point D for the moment, and we consider counterclockwise positive, and we have the moment of 40-pound force at point A. So this force is gonna make this force is gonna make a counterclockwise moment. So it will be positive. So we'll have 40, which is our F times D, and the D will be the distance from A to D, which we know is from the question 4 feet plus 4. Let's go with the other 40-pound force at point C. Again, same direction, counterclockwise moment. This time the distance for the moment will be 4. And the last one we also know from B to C is 5 foot. And if we look at this force T, we'll see that the moment that it makes about point D will be in clockwise. Therefore, we need a negative sign in here. So we'll have T times 5. And there's one thing left, and that would be the moment that we have at point D, since we have a fixed support. And since we assume it counterclockwise, we'll put a positive sign in here, equals 0. There's only one unknown left in this equation, and that would be the moment. And if we do that, we can find the moment 20-pound positive, which shows that the assumption for the moment was correct. So this would be the last reaction about point D, and that would be the final answer. See you guys next time.